Okay, so here's the third basic type of equation that we do in stoichiometry, and this is one of the more common ones. And that is when you start with grams of one of the reactants or products and you're calculating the grams of another one in a chemical reaction. So again, what do we have to do? It's always kind of the same setup. We're still using the same equation. The only thing that's different now is we're starting and ending with grams. Okay, so what do we start with? You always start with a numerical value. Here we go. So we're starting with 127.4 grams of ammonia. And now what are we trying to find? We are trying to find grams of hydrogen. So grams of hydrogen is going to be our endpoint. Now we're going to have more steps this time. We're going to have 3 steps. So we're going to move it a little farther over. Grams of hydrogen. Now basically what we're doing is we're combining the last example number 1 and number 2. We have to go from grams to moles of our ammonia. Then we'll use the mole ratio because that has to do with the coefficients. That gives us the ratio of the numbers of things to each other. In this case, we're going to be the ratio of moles. So we use that to go from moles of ammonia to moles of hydrogen. And then we'll use the molar mass of hydrogen finally to get us back to grams of hydrogen. So we've got 3 steps. The middle step in this case will be the mole ratio step. All right? So how are they set up? Well, let's see. We have to convert grams to moles. We've already done that before. So to get to moles of ammonia, we use its molar mass and we divide by it. So 17.03 grams of ammonia. Now the mole ratio step, always the same. Mole ratio. We're going to some substance, in this case it's hydrogen. Its coefficient goes on top. And our original substance, which is ammonia, its coefficient goes in the bottom. And let's take a look at how the units are doing. Grams are canceling grams, moles are canceling moles. So now we've converted to moles of hydrogen, but we need to get from moles of hydrogen over to grams of hydrogen. So to get there finally, we have to multiply by the molar mass. Okay, and finally our moles of hydrogen will drop out. Right. By the way, what I'm doing is, the way I'm setting these up is that thing called dimensional analysis that we talked about before. The point behind this is that if you set it up right, all the units cancel out and the only unit left is the correct one. So to do the calculation, 127.4, we divide it by 17.03, and this is 3 to 2, so that's 1.5, so let's multiply by 1.5. And then finally multiply by 2.016. So you notice how I step it apart into individual steps? Now, how many sig figs are going to be in our answer? This has 4, this has 4, this has 4. These are exact values, we don't worry about them, so it's going to be 4. So it'll be 22.62 grams of hydrogen will be our answer. So what we calculated is, we know that we made this many grams of ammonia. This tells us how many grams of hydrogen we need in order to produce that many grams of ammonia.